Okay, these notes are for the derivatives of inverse trigonometric functions. And to start with inverse trigonometric functions, I just want to review what we did in math analysis. So right now, don't worry about these equations. We'll talk about those in a minute. Let's just go down here and review inverse trig. So inverse trig can be written as arc sine or sine to the -1. And it doesn't matter which way, you need to be familiar with both of them. I tend to like the arc because the -1, I start confusing it with derivatives and everything. So I tend to like the arc, but you do whatever you like. So when we did this in math analysis, we talked about the domain of the arc sine was from -pi/2 to pi/2. So if we go and look at -pi/2, this is -pi/2. And this is pi/2. If I draw these angles in here, this would be pi/6, pi/4, and pi/3. And the points that go with that are going to be the square root of 3/2, 1/2, square root of 2/2, square root of 2/2, and 1/2 square root of 3/2. And then if I were going into this other quadrant, this would now be -pi/6. So it'd be square root of 3/2, -1/2. This would be -pi/4. So the answer would be square root of 2/2 and a negative square root of 2/2. And the last one would be -pi/3. So for inverse sine, we do not talk about this being 11pi/6 or 7pi/4. We talk about the negative angles, and that was explained in math analysis. So this is going to work for arc sine. Oh, actually arc sine, also this is the point 0, 1 and 0, -1. For arc tangent, this will work also, except for you're not going to use pi/2 and -pi/2 because the tangent of those angles is undefined. You have asymptotes at those points. When we're talking arc cosine, we're going to go from 0 to pi. So I would need to put the angles in there. So I have got, this is pi/3, this is 2pi/3. So that would be -1/2 square root of 3/2. Oh, and that was really sloppy. If I were you, I would write it out on your paper a lot neater than I'm writing it. And then this would be 3pi/4, which would be negative square root of 2/2, square root of 2/2. And then 5pi/6 would be negative square root of 3/2, 1/2. And you have to know these values, not can you type it in a calculator, figure it out, or do you have a half hour to figure out? You really need to know these. So all of these answers up here are given. This was just me to explain to you how this comes from. So if I want an arc sine of 1/2, that means I need to find the angle that has a sine of 1/2. Arc sine is positive in the first quadrant, so I know it has to be here in the first quadrant. Sine is the y value. So arc sine of 1/2 gives me the angle pi/6. That's why I got pi/6. And I'm not going to go every example. Let's look at number 4. Arc cosine at -1/2. I want to find -1/2. Cosine's negative in the second quadrant. So -1/2 has got to be the x value. Here's the x value of -1/2. So the angle is 2pi/3. And then let's do a tangent. Let's do number 5. Tangent. So if you look at these values, sine over cosine. So remember, sine of theta is equal to the y. Cosine of theta is equal to the x value. And tangent of theta is equal to y over x. So I want the square root of 3/3. Well, this one right here is a negative and a positive, so I know it can't be that. So it has to be in the first quadrant. Tangent's positive in the first quadrant. If I take 1/2 divided by the square root of 3/2, I get 1/2 times 2 over the square root of 3, which is 1 over the square root of 3, rationalize the denominator, and I get the square root of 3 over 3. So arctangent of square root of 3 over 3 is this angle pi over 6. Now I'm actually going to go through these. I highly recommend, encourage, demand, I don't know how you want me to say it, that you watch the videos for AP Classroom that I've assigned, because she goes through how these are derived and gives some really good advice. I'm just going to go ahead and give you these 4 examples, and then I want you to watch those videos from AP Classroom, or it doesn't matter to me the order you use them. Okay, so what I want to look at first is I've got this 2x, so I need to use a chain rule. So the way I'm going to do it here is I'm going to say u is equal to 2x. So I know u prime is equal to 2. And on the front, I'm going to write with the formula here. On the front, I've got d dx arc sine of u is equal to u prime over 1 minus u squared and the square root of that. So now that I've identified what u and u prime are, I'm filling everything into the formula. For AP Calculus, you do need to understand and memorize these formulas. So when I plug this in, u prime is 2, so d dx arc sine of 2x is going to equal 2 over 1 minus u is 2x. And I keep reminding people, this whole thing 2x is squared. If you don't write the parentheses, it's going to get marked wrong. So I make sure I use the parentheses. I do square root. You can leave it like that. You can simplify it. This would be 1 minus 4x squared. And that would be where you would stop there. On a multiple choice question, you just need to find the correct answer. And it's going to be difficult because all of these equations look the same. All these formulas look the same. If you're doing a free response question, a lot of times you're then plugging a number in. You can leave it in unsimplified form. So my next one, I have arctangent of 3x. So I'm going to let u equal 3x. So u prime is equal to 3. Let's see, arctan of u. So if I take the derivative of arctan of u, I get u prime over 1 plus u squared. So the derivative of arctan of 3x, u prime is 3, 1 plus u squared, so 3x squared. Notice I put the parentheses. So I get 3 over 1 plus 9x squared. I have arc sine. Once again, I should have put a cosine, but I didn't. So u is equal to x to the 1/2. So u prime is going to be 1/2 x to the negative 1/2. So when I take the derivative of this, and I've got the formula back up here, the derivative of arc sine of the square root of x is going to equal u prime, so 1/2 x to the negative 1/2 over the square root 1 minus x to the 1/2 squared. I can clean this up a little bit. This 1/2 is the same thing as saying 1 over 2. So I'm going to do that. 1 minus x to the 1/2. X to the 1/2 squared is x. So I'm going to have 1 minus x here. Then I have this x to the negative 1/2. That's the same thing as saying it's going down here, the square root of x. So this is totally acceptable. You might see it written like this, 2 square root of x, square root of 1 minus x. Some people will multiply the square root of x in there. So I get 1 over 2 square root of x minus x squared. Every one of those forms is acceptable. These would probably be the two more common that you'd see on a multiple choice test. but there's nothing wrong with this one here. I have a secant next. So secant, this one's got a lot more going on because it's e to the 2x. And we've done transcendental functions being exponents and logarithms. So we're still going to have to use a chain rule. So my u is going to equal e to the 2x. Remember, the derivative of e to the x is e to the x. But then I have to multiply that by the derivative of 2x. So my u prime is going to equal 2e to the 2x. The formula for secant arcsecant of u equals u prime, absolute value of u squared minus 1. So I'm now going to come along, plug everything in I know. So the derivative of the arcsecant of e to the 2x is going to equal u prime is 2 e to the 2x. Absolute value of u is e to the 2x. Yeah, put absolute value bars there. And then square root u squared, so e to the 2x squared minus 1. To clean this up, and there's going to be a little bit of cleaning up on this. This is going to be 2 e to the 2x. Okay, e to the 2x, every exponential function is positive as long as there's not a negative in front of it. So a graph of an exponential function looks like this. All the y values are positive. So the absolute value bars don't mean anything. So I can take away those absolute value bars. Then I get the square root e to the 2x. E to the 2x times e to the 2x is going to equal e to the 4x. It's e to the 2x times e to the 2x. When you multiply, you add exponents, so 2x plus 2x is 4x minus 1. You'll see that e to the 2x is here and here. So I get my derivative is 2 over the square root of e to the 4x minus 1. Once again, I've changed up the order I've taught these. This is usually taught towards the end of the course, right? At the same time we're doing integration, and I felt before that it was good to put it there because before the AP test, and students would then get to get it exposed to it right before the AP test and have a better chance of memorizing it. But I'm keeping pace with what they're doing on AP Classroom, and I think this is a very good move because then we can continue to use this throughout the course.